All right, so let's talk about the partition matrix. There's a special type of partition matrix that we're going to look at, but before we get to those, we're going to look at how you partition a matrix. Partitioned matrices. Writing there. So partitioned matrices. All right. Let's say you have a matrix that has m rows and n columns. If you cross out some of them, but not all of them, you can give something called a submatrix. But before we get to the crossing out, let me show you what they call a partition matrix. Let's say we have 1, 2, 3, 4, 5, 6, 7, 8, 9. If I were to partition this matrix, look like this now. To go to, let's say, make it look like 1, 2, 4, 5. Let's do like this. So 3 and 6 are over here. 7, 8, and 9 are here. So end up with 4 different matrices from the one. Let's say we call this equal to A1, 1. That's the one over here. In the first row, first column. Then right here now we have a different matrix. Can call it A22. A12, sorry. It's in the first row, second column. Then below that we have a next matrix. A21, that's the first row. Sorry, beg your pardon, that's the second row. First column. See, it's down here. First column. And last we have the 9, which is in the second row and the second column. That's A22. So we get 4 matrices, not all of the same size as you can see. But from that one partition matrix, we get these 4 different matrices over here. How can this work? What can I do with it? Well, we shall see soon. But before I give you definitions, I just want to show you that there. Before I give you some full definitions, I want us to yeah.
Sir, I don't know if it's just me, but I'm not seeing your screen properly. It's appearing to more towards the right side. Like I'm not seeing properly. Like if you could just scroll down or something.
I'm looking at it properly, so see if you can move it now and see if it makes a difference. Are you trying to fix it?
Yes, sir, I got it. Thank you.
Okay, good. All right. Boom, 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 boom. So a partition matrix is just creating partitions. Simply put, if you create different partitions in the matrix, you could do many of them, by the way. You could do one up here like this. You look at it there. You could anywhere you want to cut it. You just get a partition matrix. That's not going to be that important, except for a special augmented matrix you're going to have when you're doing some solving for linear equations. But something that's important from this is what we call a submatrix. Give the definition for that. So the submatrix partition is a bit different. So write this down now. What is a submatrix? I'm going to be using this a lot. All right. If you cross out, write this down now. If you cross out some, but not all, the rows or column. If you cross out some, but not all, the rows or columns of a matrix. If you cross out some, but not all of the rows and columns of a matrix, it creates a submatrix of that matrix. So if you cross out some, but not all of the rows or columns of a matrix, it creates a submatrix of the matrix. For example, So we had a matrix X like this. Say 1, 0, 4, 6, 8, 2, 9, 2, 3, 6, 4, negative 5, 0, negative 1, 8. What's this? It must be 8. All right. So if I were to cross out, let's say this one here and that one here, we get a submatrix. And that submatrix would be, look at what is left. 1, 0, 4, 8, 4, negative 5, 0, 8. So this matrix down here is a submatrix of the one up here because it comes from it by crossing out, well, one row and one column. So it's pretty simple. So once you get a submatrix, once you cross out some rows and columns from a matrix, a matter of fact, it could be one row, it could be one column. So it doesn't have to be a row and a column. If you cross out a row or you cross out a column, you also create a submatrix. So if I just crossed out the top one here alone and left the rest down here, that's still a submatrix. But it has to be the entire row, the entire column. You can just cross out one entry. That won't create a matrix. It'll create something missing.
And do we have a name for the submatrix now?
Well, you have a special symbol for it, but I'll tell you about it soon. Not yet. Yeah. I just want to know how it is formed. But before I get to the forming of the matrix, I want to show you how to do a special multiplication using the partition matrix though. This one took me a while to catch the first time I saw it when I was a student, but let's see, you guys are brighter, so you can get it quicker than me. So let me give you an example of that. Let's say we have, here's a nice one. So suppose A, let A be equal to, we'll have to be very careful now so I don't make any mistake. These always can be tricky. 1, 0, 2, 1, 3, 0, negative 1, 2, 0, 0, 1, negative 4, 0, 0, 3. All right. I'm going to partition this matrix. Matter of fact, the reason I was taking so long to write is because I was looking at partition first. All right, let's say we partition it to look like this. So we have partition in the middle here, so we're going to turn it into 4 2x2 matrices, which we will call A1, 1, just like I showed you before. Sorry, that's 2, 1. Over here is 1, 2. All right, as you can see now. And then we're going to have a next one. Let's call it B. And B is a 4x6. So it's 2, 0, 0, 1, 1, negative 1, 0, 1, 1, negative 1, 2, 2, and 1, 3, 0, 0, 1, 0. And finally, oops, negative 3, negative 1, 2, 1, 0, negative 1. All right. So we're going to split B into four matrices again. Let's say we have it split it down the middle here. Let's middle it again, yeah. So we'll get the next set of matrices here. So we have B1, 1, B2, 1, just like before, B1, 2, B2, 2. All right. Let's multiply these now. This is where the nice part comes in. If we were to multiply AB This A, B is up there. If you want to multiply A by B, you have to be very, very careful. Now, see if you understand how I get these numbers now. I'm going to do the first two rows. Or that's the first row. So I'm going to multiply A, which is this over here, by B, which is this over here. Watch now. Let's assume, let's just look at A11, A12. If you're multiplying two matrices, you multiply rows by what?
Columns, sir.
Columns.
Good. So we're going to multiply these rows, well, this row by this
So can
column.
you hear me?
I'm hearing you. You have a question?
Can you hear me clearly?
Yeah, man.
No, sir.
All right,
Okay,
when you say
now you can
columns.
hear me clearly. That's good. All right.
Okay.
Okay.
Because what I've seen students mistakenly do is that they say, oh, is this times this? That's A11 times B11. And they go to this times this one over here. No, you have to be careful. Because they will multiply, say they multiply this by this, and then this one by this one, and then this one by this one, and they get stuck because they get the wrong answer. So, watch me now. Row, remember if you're multiplying two matrices, you know, if you're using A times B, and we're using these over here, it has to be the first row here by the first column here. But based on how we have it, it is actually A11 by B11 plus, well, not plus, and then this one here times this one down here. That's a row times a column. So let me see if you guys get, what do you think is going to be the first number in this matrix right over here? Based on what I just told you.
Sir, based on what you're explaining, it's going to be row by column. So 1 times 2 plus 0 times 0. There's a 2 plus, oh, confusing. Hold on. Row by column.
Or what are you multiplying? The original A and the original B?
Yeah, well, this by this.
So,
Well,
sir, are we going to use the 1 0 in A11 to multiply the 2 0 0 1 0 1 in B?
Wait, hold on. You're confused. Am I going to use what?
1 0,
Uh-huh.
which is in the first row of the partition matrix in A, to multiply the 3 columns in the partition matrix in B.
Not necessarily. You're going to do it like this. It's going to be this times this plus that times that. I never said that right for you to understand. It's going to be A11 times B11 plus A12 times B21. Row by column. Row by column.
Yeah, we get the
All
part.
right.
So,
Like that.
sir, maybe if you actually work it, it will come through.
Repeat that.
If you actually work it, because I still don't get something.
Yeah, man, I'm going to work it. I just want to see if you guys can figure it out based on what I said without working it. You know, I will work it out.
A11 row.
All right. Only hearing both of you. So let's go through then. So here we go. Because you know it's row by column. So the first row contains these two entries. Based on the little diagrams up, this smaller matrix over here. It's going to be the first row A11 and A12 by first column right here. So we're going to multiply A11 by B11 and add it to A12 by B21. So let's multiply A11 by B11 first. So it's this one little group of 2, right? Well, 2 by 2 by the 2 by 3. So as Akeem was saying at the start, 1 times 2 plus 0 times 0, that's 2. No, finish, you know. That's just for this first
Oh, that's there.
modular.
Oh, God.
You know, finish, but you don't finish it. You didn't say plus. That's the problem. I wanted to hear the plus.
Oh, God. All right, sir.
All right. You go ahead then. What's next? You know, finish it up. The youth and maturity himself. Oh, God.
There we go.
So you have to multiply
1
the
times 0.
same row by the second column.
The same row. So you're saying this here by what?
By the second column
Middle
of
one.
B11.
This?
B11, sorry. Yes.
All right. And that give you what?
Yes, sir.
So 0.
All right. Keep going.
The next one also gives you 0.
So plus 0 again.
And then so all of that will be added. Oh no, I didn't know.
No, sir. I think
the second row by all the columns.
Sir, I don't get where they're coming up with those answers. Let me see if, because
because it's not quite right. It's not quite right. Hold on. Tell you what. Hold on, Harold. Assume that we just had this and this. Just those two. Forget everybody else. So you would end up with this. You'd have ended up with somewhere else. You'd have had 1 0 0 2 multiplying 2 0 0 0 1 1.
Oh, so that is what I was thinking now. So 1 times 2 plus 0 times 0.
Mm-hmm.
And then 1 times 0 plus 0 times 1. 1 times 0 plus 0 times 1. And then the bottom row now, 0 times 2 plus 2 times 0. 0 times 0 plus 2 times 1. And then 0 times 0 plus 2 times 1.
All right.
I prefer to do it that way, sir. Popping up with the answer, it doesn't make any sense. I prefer to work it out.
Okay, fine, but try it until the number you get the first number you get. That's what I'm waiting for still. I'm still waiting for the first result right here.
I have to go write it down, sir.
No problem, man. Take your time, man. So I was wondering where everybody was getting so fast. It's not 2.
It's not 2.
It's not 2. You're going to end up with somebody saying something? So this one tricky, you know?
Sir, can we say we're going to end up with?
4 by 6.
What kind of matrix will we end up with?
Complete 4 by 6. You're going to have an entry here, here.
It's just a one little section there?
No, one little section is a 2 by 3. That's going to be the final result. This.
Like that's what I want.
Let me see something here. What I'm asking for is the first result right here.
I'll come in, sir. Go and give you. I'm just working it out.
All right. Starts with T. It's not 2. Who? Answer for man. If you do what I tell you, like what Harold is doing, you get it long time, you know?
I'm not suffering. I'm working it out. Me, all right.
And I told you how to get it too. It's going to be these two and these two.
It's supposed to walk me up in the I'm saying.
Anyway, when you guys finish and you realize, oh, it was just that, you'll figure out how easy it was. Because even though I suggested what you should do, you can do the shorter way than that. It's the same thing that you've been learning all along. You just don't realize it.
All right, sir. 202042.
2. Oh, that's the answer. So you're saying 202042?
Yes, for that piece there in the second quadrant based on the graph.
Not quite.
All right, I must go too far.
I think you forgot.
All right, sir, I have it.
Where you get?
Have it. 2. All right, so going erase that, sir. Going across 200,022.
022.
That's the same thing I got.
Oh my goodness. All right, so let me tell you. You get the 0 right, and yeah, that's it.
Huh?
1 and take it right. The
What?
0 here. Imagine
Sir,
that.
just the zero I got.
Jesus. I know.
Mm-hmm.
I got this. Sir, I liar.
Not true, man. Not true.
I copy like my dad.
Let me give you that hint.
No, sir.
Remember, I said this. Anyway, no, I forget that. Let me go back to the basics so you guys can remember to do it. First row by first column. That's it. I forget, man. Start focus on this alone. And
1 times 2 plus 2 times 0.
uh-huh.
And then in the middle, 1 times 0 plus 0 times 1.
This by this.
No, the 1 0 times the second column.
You read second column yet?
No, sir. Isn't it the first up here? So where the A is, isn't it 1002 by 200011?
Oh, you're talking about this?
Yeah, isn't this what we're doing
No,
in here?
man. No.
No, all of it, sir. 200011.
Sir,
That's not
so
it.
aren't we ultimately trying to find out what A11 A11 times B11 plus A12 times B21 is equal to?
Correct.
Yeah, so in order for us to do that, the first step will be to multiply A11 by B11. And then the answer you get added to the answer you find for A12 multiplied by B21.
Correct.
Yeah, so
All
So
right,
what happened?
Sarah, like how you have it in theory, work it now, please. Let me see what is it.
Because I haven't heard the first number yet.
That's just your.
She's right. As I say in
okay,
theory.
sir, give me some time.
Okay, no problem. I'm going to give you guys 2 more minutes. That's it. All I want is the first number.
I'm working it based on the principles of matrices, so I'm not sure.
Theory, you know.
But if you even ignore the
Theory.
little sub things over here, if you what she said about it, if you ignore that, and that's good. I'll show you how to do it fast way.
Row, column,
Boom,
row,
boom,
column.
boom,
Sir,
boom.
if you can do it that way, what's the way of breaking it up into 4 parts? What's the point of that?
Because I could give you a partition matrix like this and ask you what will be the result if I multiply the same thing I just asked. I could have asked you what is this one times, say, this one here.
But sir, what I'm saying, in B, you have the answer for AB, you have 4 sections, right? So isn't it the first quadrant times the first quadrant for the first quadrant and continue like that?
First quadrant and first, no, not necessarily.
Oh,
Because you still have to apply the rows by column.
yeah, I know, but initially you wrote 1002 times 200011. So I'm assuming first quadrant equals first quadrant.
Oh, that's what I mean. Well, it equal a part of the first quadrant.
Yeah, that's what I'm saying. So it would be 1002 times 200011 for the first quadrant.
No, if you do that, you're forgetting the plus.
Yeah, man, including the plus.
Well, if you put the plus on, you get it, yeah. So what I'm actually asking for is, so what you mentioned this times this. But to get the answer right here, you need to add that times that.
Yeah, so 1 times 2 plus 0 times 0.
I'm writing it down, so you're saying it. 1 times 2.
Yes, plus 0 times 0.
Mm-hmm.
1 times.
Continue.
1 times 0 times.
And then 1
That is the A11, B1. But
Yes.
so far you have mentioned this.
Yes, and then the 812 now would be 1 times 0 plus 0 times 0 times 1.
No, that's a mistake you're making.
Sir, me have it. Me catch you now, sir.
Sir,
Aaron,
so
listen this.
So before you go to him, I just have a question. I understand the way that you want us to work it out, right? But what I'm trying to figure out is what's wrong with the way that Harold is suggesting, because can't you do A11 times B11, then you
Harold
find
is saying
A12
no.
times B12 and then add the two results? Can't you just do
Yes,
that?
but Harold is saying this times this. Then he went to this one. Is that what you are saying too?
No, so I'm saying that the first row in A11 should be multiplied by all the columns in B11.
Right. So I'm saying be careful. You say what you're saying is what Harold is saying. You're saying two different things.
Okay.
Sir, you have to go do
Sir,
this one because I'm lost. Oh,
Okay. Shanice, I got it though.
have it, sir.
Go ahead. Akeem.
You want the answer or you want the process?
Let me hear the answer first.
2 0 going in rows.
Hold on, no man. Give me the answer for that you get first.
Yeah, man.
The number that's
Yeah,
supposed to go there.
the section. All right, so 200 going across
Oh, you're gonna cry. Oh.
and 022.
Nope. Once
I
again, I get
think
the
what did
zero.
you just say?
No, I think he changed it.
2000.
He changed it to 2022.
sir, I'm saying it doesn't have to be hard. You know, my approach to this is that I'm looking at it from each quadrant. So the first quadrant times the first quadrant equal the first quadrant, and then I do the second one, the third one, the fourth one. So I don't see another way to do it.
I get you. All right, hold on. Shanicia, how do you get a number?
So you said the row times the column. So it's like the 1 times the 2, the 0 times the 0, the 1 times the 1, and the 0 times the -3.
That is it, ma'am.
No, hold on. No, sir. You're not get over this. No. How we reach down at the bottom piece down there, so.
Yeah, exactly.
Where is B21?
Oh, Jesus, please. Hi.
Because
Hi.
sir, what you write on the screen, you know, is initially 1002 200011. So it gone to the 3 now.
I did say it. I said you have to multiply these two by these two. I didn't say that.
Yeah, you said that, sir.
Then what you talk about? So let me write out quickly.
All right, sir, your turn.
Stress me, no.
All right.
All right. So here we go. So I'm just write out the list that we're supposed to get here. So for the first result right here in this little box, to get it, all right, let me just write down these. Make it life easy for you. When you multiply those two, you're gonna get C11, C12, C21, C22. Oops, 22. C11 is equal to, look carefully now, look up at the two matrices we have. A11, see it here, times B11 plus A12 times B21. Agree? Same thing I'm showing from morning. See it here? So this by this to get this.
Yep. So we see that part.
Then like that. So all you have to do is multiply 1002 by this madness right here. But you guys are forgetting the plus this one times this one down here. That's what you were forgetting a while ago. Is it any better in understanding or?
Oh, so I have to add.
Yes, man, the whole thing.
No,
I'm not gonna write this down.
it's not
Need some speed.
using the A11 and the B11. When you do it by the figures, it's probably make more sense.
So hold on, say that again, Harold.
The algebraic part, the C11 and the A11 not making the connection. Maybe the actual working out would help. Like
Yeah, man, I'll do it. I'm going to do it. But think about it, man. Let's say you had numbers here, number here, number here, number here, number here, and number in all these. You would have done that. You'd have done this by this, wouldn't you?
Yes, sir.
Good. Okay. All right. So let's figure them out now. So this is 1002. B11 is this long something right here. So all right. So let's work it out. I'm going to erase this because I want to be able to see both of them at the same time. As a matter of fact, I'm just carry them down here. Can I minimize? No, make it see. Get this out of the way so we can see what is happening. Go one side. All right. So, scroll down a bit so I can see up there. 1002. So that's 1002 times 200011, which is going to be 1 times 2, this times this, plus this times this, as all you were saying from morning. That's 2. Next, we're going to go, remember, we're going across, you know. So all I've done so far is this first line by this first line. Keep going. This now is the A12 part. We're not finished with this one yet. But if you, matter of fact, I must do it long way, so you guys can understand fully what is happening. That's the first entry for up there. Then go across now to what you guys are saying. This times this. Sorry. I'm just going to multiply these two, A11 and B11. Not changing anything else. I don't want to get confused. I'm going to go right across. So 10 times 01 is 0, as you all said. 10 times 01 is still 0. Good. Let's go down to this one second row now. Second row times the first column is going to be down here. So that's 20 times 02 is 0. And then, let me reach again. Oh, 02 times 01 is 2. And the same thing again, 2 again. That is so far the I just think you can throw away. So we've multiplied this matrix so far by this one. It not done. Plus this one here now times the one times this one down here. That's why you keep forgetting to add the plus.
All right, sir.
Mm-hmm. Go ahead.
All right, so I'm not break it, but we get the answers there. But
Okay.
let's tell us again. 330 612
Yes, we're talking. 330 612. That is it.
Yes. All right, go on over there to the class, sir. We catch you again.
All right. So we're going to multiply now. So far I've done this by this.
And there's a
Now I'm going to go to this one by this and add them. That's just to get the numbers up here, saying. So it's going to be, and the reason why I have to make sure you understand it is because if I give you these things with variables and ask for a specific part, I remember someone was asking, why you can't do it the other way? You are going to have, anyway, you know what? Make sure you understand what I'm showing you. I'll put it that way. So when you get the question, you can ask me if I teach you. So 10 times, so multiplying this matrix here by this matrix down here. Oh, you're close, Raquel. So 10 by 1 negative 3 is going to give us 1. Whoops. 1. And then we have 10 by, wait, let me reach. Oh, 3 negative 1, we're going across again. That's 3. Then we'll go 10 times 02, that's 0. I'm going to go down now, which is the 3 negative 1 by the same things across here. Well, actually, this one by this one, then this one, and this one. So 3 negative 1 by 1 negative 3, look like 0. No, that's 6. 6. 3 negative 1 by 3 negative 1, that's 9 plus 1, that's 10. 3 negative 1 by 0, negative 2, that's, 3 negative 1 by 0, 2, that's negative 2. Add them together now, and you should get the results that Aki mentioned. 2 plus 1, 3. 3 plus 0, 3 plus 0, 3. And 0 plus 0, 0. And 0 plus 6, 6. And 2 plus 10, 12. And 2 plus negative 2, 0 right here. That's what I've been saying from the morning. But you have to remember that. But if you get stuck with that, and it is set up like this, you won't have a difficulty as long as you remember that you can do it this way. This by that. You'd have gotten the same answer already for a long time. That's what Shanice did. First row by first column gives you the first entry. If you kept going the same way, first row by second column gives you the second entry, and so forth and so on. You've got the same result. But it is essential to know the partition one for when you get variables and a split up. I might leave a certain part blank and put variables over here and put some partitions and thing and put some dotted lines that numbers are missing. You have to figure out how to get them by using this partition stuff right here. Okay. Any questions about that?
Just need a
Yes,
little practice, that's it, sir. But I think well, I think I have.
You know, once you stick to the methods, if it's either row by wait, Harold was the one I was asking. Harold, catch it now?
No, sir, not at all.
Very quiet, sir. You understand how I got these numbers here?
Sir, that red thing that moving on the screen, is the AI doing that?
That's me pointing. I'm moving too fast? Let me put them
No,
again.
that was the AI dictating a move.
Oh, no, that's me.
Okay.
So this A11 by B11.
1 times 0, 0 times 1. That's how I do it.
Go again?
How I do it is 1 times 2 plus 0 times 0. That's how I do it.
That's ready to get what? The 2?
Yeah, so I'm trying to connect the steps to see how you get the 0, the 1, the 3, etc.
All right, come on, let's go again. So let's work with the 2 first. As you correctly said, remember it's A11 times B11. That's why I got all these numbers right here. All right. So to get the 2, you correctly said 1, 0 times 2, 0. That's why I got this 2. Keep going across. 1, 0 times 0, 1. That's why I got the 0 right here. You okay with that?
Yes, sir. And then 1 times 0 plus 0 times 1.
Right, so I got this 0.
All right.
That was the first row going across the first with the column, sorry.
All right.
That's what the top one. Then we go to the 0, 2 now by each column to get the numbers down here. So check them and see if you understand that.
Oh, all right. I see that part. Oh.
So all of that was just A11 times B11. That's this little section right here. And then A12 going across the row, multiplying the column down here. Because remember it's row by column. So multiply 1, 0, 3, negative 1 by 1, 3, 0, 1 down here. Same process I did available. It would have been A12 by B21.
Oh, I think what is misleading, sir, initially you put 1002 times 200011. So I thought we were just going to isolate that part.
Yeah, to get the A11, B11.
Okay.
So maybe when I was saying it at first, you only heard that part, but you didn't hear the plus this part times that. That's what probably, so you were probably fixated on this 200022, whatever.
Yeah.
We don't remember to add it.
Yeah, how I work out these things, sir, I like to write each step. That is how I understand it. I can't shortcut like Akeem.
No, shortcut, it was actually the same process. It was that maybe Akeem didn't write the, well, I don't know if I don't, didn't they say Akeem, what did they do different?
For example, question like this will take me 2 pages because I write every single thing.
2 pages? Well, no, you're going to take too long now, man. That might take you too long. But anyway, I wouldn't give you something like that. This too long. I mean, this is a 4 by 4 by a 4 by 6. You know, sir. This is just, I wouldn't give anything that long. I wouldn't have asked for the whole thing anyway. Probably just ask for one section, the next section. That's why it's important to know the how to get to that section, not the whole thing. I wouldn't know. I'm not hearing properly. Who's talking? One person gone. Akeem, who's Akeem? Okay. All right. Spent much time on that, you know. That's not the meat of the matter right now. Because if you get a question from me, probably just one little question, especially for the final exam. The meat of the matter is going to come from inverse matrix and stuff like that. But just to ensure everyone understands, so if you were to find the result down here, that's the bottom, that's C21. I think I moved it. Where moved it? Oh, don't so. Let's make sure everybody understands now. Put this back. If I'd asked to find, yeah, if I'd asked to find this result here, the result down here, which would be C22, what would you multiply and add to get C22? To get down here, what would you multiply by what and what? I showed you this before, not just today. If you're using these two, multiplying these two to get the result down here, C22, what would you multiply? What row, what column?
Sorry, A2.
Right, I hear A2 when I hear this. You finish? Oh, you're on the right track, by the way. Who's Raquel? Raquel, you ship out. I'm not hearing you right now. Anyone want to help Raquel, or she's the only one understanding? That's why sometimes it's good to have a keen. I might talk a bit much sometimes, but you always try. Oh well. All right. Oh, Tammy's back. Tammy's back. Oh, he's back. Akin, you hearing me? Raquel, I know you're trying, but you might chipped out.
Hear me?
Yeah, I'm hearing you now.
So you're saying, yeah, I got kicked out the internet.
I was
I finished the
asking.
question. I almost finished the question, but all right.
Yeah, depend on that. I was asking if you were to, if you wanted to get this result down here, this column, these entries right here, which is C22, what would you multiply from this and this?
Pardon me, sir, but I'm not seeing the screen. It's loading, so I'm not
Oh,
able to.
loading.
It's loading.
All right, no worries. So people, it is the fourth group of entries. As you can see, the fourth one right here. You'd have just multiplied the second row by the second column. That's it. I did tell you that before. If you have 4 entries, 1, 2, 3, 4. Look at where they're located. If you want to get the first entry, the C11, multiply first row by first column. If you want to get the entry in the first row but it's in second column, multiply the first row by the second column. It's as simple as that. If you want to get the entry in the second row, first column, multiply the second row by the first column. So if you want to get the second row, second entry, second row, second column entry, multiply the second row by the second column. It's not complicated.
So it is
if you want it.
to give us the C22 then for that one.
Come again?
The A22, the B22 to get the C22.
You mean these two?
Yeah, for the last
No. You have to use the entire row. So you have to multiply A21, A22 by B12, B21. Them two something. B12, B22, right? So it have been this by this. Each of them you need the entire row, the entire column. Not just the last one. Because if you do that, you're doing the same mistake that you made for A11, B11 to get this. You have to include A12 and B21 as well. So it's the entire row by the entire column to get C22. Get it? Wait, where's Harold gone to? Oh my. I hope you catch a recording. All right. I think I can give you a simple one. I'm going to give you a simple one to see if you get it done. Let's do this quickly.
Sir, I'm back now.
Welcome back, man.
Sir, I'm back.
Yeah, man. Ask the question already and give the answer, so it's all right.
Okay. Cool.
The question, let's see again. There's a nice question I saw in the book. Here we go. So, let's say we had, it's a nice example in the book here. We had B being equal to, I think it was 2, 3. Yeah, 2, 3. C being equal to 1, negative 1, 0. And D 9, 6, 8, 7, and negative 4, 5. All right. And the book asks, what is BD? Very simple, very simple. All you do is combine this one here with this one here. You notice, isn't it? That's the multiply them, you know. Matrix B would just be B, which is 2 and 3. Put the D beside it, because the D is, oops. The D is beside it right here. You just put the D beside it right here, going across. Sorry. Which is just 9, 8, 4, or negative 4, 6, 7, 5. Nice and simple. Everybody okay with that? All right, wrong question. Anybody confused by that?
No, sir.
Yes.
No, sir.
All right. So suppose now they ask you to do this. Let's say what a nice example they had again. They had a nice one. Oh, by the way, before we move on, can we multiply B by C and get a result?
Yes, sir.
Yes, sir.
All right, let's do it. B, C. Who tell me what to write now?
Somebody want to go or I can go?
Can I go ahead, please?
Yeah, go on.
Okay, so in the first slot we will have 2 by 9 plus 2 by 6.
It's BC.
Hold on, I think you're using
Oh,
B.
sorry. I'm so sorry.
No problem.
That'll be 2 by 1 plus that's now
Right.
2 by 1 plus 2 by negative 1
Not
plus
quite.
not quite. Okay, just now let me rethink this.
First of all, think about what kind of matrix you're going to get.
2 by
We're gonna
3.
get a 2 by 3.
Ah,
Okay, that's true. That's true. Okay, so you're gonna do 2.
it's actually easier than you think. Put it this way, there's no
Yeah.
plus.
Okay, I figured that out. 2 by 1, that's in the first slot, and then 2 by negative 1 in the second column, and then 2 by 0 in the third, 3 by 1 in the second row, first column, 3 by negative 1 in the second row, second column, and 3 by 0 in the second row, third column. Yeah, thank you.
There you go. Correct. So it's going to be a 2 by 3. So let's get these results here. If you were to segment this thing, just like I did a while ago, if you had put B11 up here, C11, C12, and C13, you'd have realized that I get the same results that is. But anyway, that's not the part I wanted to get to. What I wanted to get to was this thing. If I can squeeze it up right here. You'll go one side. So one space. All right, suppose I asked to find now DC C transpose. What's that?
Sir,
Uh-huh.
I was waiting for this one, I know you'll come with this, You go put the CT in front and times it by the DC result.
I know multiplication,
You said DC, that's the matrix.
It's not a multiplication. It's a matrix.
Oh, come here. Me lay wait here,
Not this time.
So you're going to put the matrix D on top of C and then put it next to C transpose?
Just tell me the numbers to write.
Okay, so you're gonna have 9, 8 of -4. That's gonna be okay, and then 1.
Oopsie.
Oh, sorry. Okay, let me come back to that. So 9, 8, -4, and then underneath that you have 6, 7, 5, and underneath that you have 1, -1, 0. So C transpose is not like 1, -1, 0, but in column format.
Right, it is. Oh, so you're
Yeah,
telling me the
so
one beside the -4?
yeah, that's what
Oh,
I was talking about, yeah.
no
So
problem, no problem.
1, -1, 0, yeah.
Correct. Well done.
So, sir, all
That
of
is
them
it.
combined to give you one matrix then.
Right. I
Right.
said, I have to make sure to put the lines here. You notice once you see that, you know it's a matrix around the whole thing.
All right.
If they're asked you to
Sir.
multiply, you want to put the brackets here. Yeah.
So what would make me not think it's multiply? Can you catch me now?
These.
So doesn't that I get the DC part and the C transpose?
Uh-huh.
The space between the DC matrix and C transpose. My brain is telling me it was multiply.
You see, if I didn't put these, this and that, multiply.
Oh, all right. Okay. I got you. Thank you.
All right. Come on. All right. That covers everything else. Good. So we can go to some more definitions now. So next class we can be finished with this definition business. All right. Non-singular. I figured out a way to not be confused by these two things. So non-singular and invertible mean the same thing. Get rid of this. Non-singular and invertible mean the same thing. An invertible simply means you can multiply the matrix by a certain matrix to get the identity matrix, meaning it has an inverse. Remember, for the people who weren't here, let me just repeat that because it's important to remember in math, especially when you go to, if you want to go further in math and you want to do proofs, if you don't know what identity and inverse means or what they are used for, it doesn't make any sense to go any further. Addition. The identity for addition is 0 because when you add 0 to any number, you'll get back the same number, regardless of how you write it. So therefore, 0 is the identity for addition. Each number has an additive inverse because you can, any real number in the world that you think of, if you add it to the negative of it, it becomes the identity. And so we mean add it to negative of it. Suppose you're adding -3. Yes, add it to negative of it. The negative of -3 is +3. So you get the same as 0. So it's added to the negative of it. So if you want to find the identity, if you want to find the inverse of any number by addition, just add it to the opposite side of it then, if you want to think of it as not negative. And so this is the identity, 0. To get the identity, use the inverse. So that's how inverse and identity works. So let me give you one that I didn't give you before. Since I've mentioned this before, let me just ask you guys something to see if you're catching on. Let's say we're talking about division. What's the identity for division?
So you cannot divide matrices.
Come on, I'm talking about real numbers. Sorry.
Or real numbers.
Multiplication.
No, division I'm asking about. What's the identity for division?
Identity for division. It doesn't have an identity.
It doesn't?
Isn't it multiplication, sir?
Me asking about division. Division.
Which number you divide by itself to get back the same or multiply?
Alright, so since you see, I mean, someone really understand it at the end. We'll go again.
Wait, so
The ident-
what was the question? What are you trying to
What
find
is the
out?
identity for division for real numbers?
Identity for division.
So is it 1?
Yes, it is 1.
Oh,
Every number divided by 1 is the same number.
sir, that is such a okay. All right, no, you win. All right.
Me think everybody else at one same time. I didn't know there was a bit of confusion. After me just explain the thing a while ago. Let me go
I
again.
feel
The identity for addition is 0 because when you add 0 to any number, you get back the number. The identity for division is 1 because when you divide any number by 1, you get back the same number. Every number in the world that applies to. The identity for multiplication, everybody knows it already, is what?
1.
1. Because when you multiply any number by 1, you get back the same number. The problem is, not every number has an identity in division. Sorry, I said the wrong thing. Not every number has an inverse for division. Sorry. Which number is that? Which number doesn't have an identity for division? An inverse for division.
-1.
Which number? I feel like which number?
Doesn't have an inverse.
I'm guessing that it has to be 0.
Right. Because you cannot divide 0 by any number. There's no number you can divide 0 by to get 1. Remember, the inverse gives the identity.
The inverse.
So for the people who are confused, let me start all over. Because it's important.
Sir, can you scroll the screen? I'm not able to move it. Please.
Try again.
No, sir. Still not working for me.
You still can't move it?
No, sir.
Let's do that.
Aniva Campbell.
You might have to refresh. Because is anybody else having a difficulty moving the screen?
I usually can't move it, sir, but with a screenshot.
I can move it.
Thank you, Harold. Refresh Aniva. You should be able to move it.
All right, sir.
All right, where was I? Oh yes, I was talking about addition again. So I want to make sure everybody understands how identity and inverse work. All right, let me just talk about all the different operations. Addition. First, identity for addition, 0. Because 0 plus every number is 0. Identity. Oh wait, let me do it a different way. Let's build in table format. Identity, inverse. So when you're adding numbers, real numbers we're talking about now. When you're adding numbers, the identity is 0. Because when you add 0 to any number, you get back the number. What's the identity for division? 1. Because you divide every number by 1, you get back the same number. What's the identity for multiplication? Multiplication.
1.
Right, same 1. And of course, subtraction and addition is the same thing, just like division and multiplication is the same thing. I did say that before. But I wanted to see if you guys understand. Well, the ones who weren't here, see if they catch it. No, the inverse is going to be different. What is the inverse of x under addition? Negative x. So using x, inverse for x. What is the inverse of x for division? So negative x.
Is it X?
Right. Except for what?
Except
0.
for 0, yeah.
Right. Every other number divided by themselves, you get 1. You get the identity. So remember, you know, for a number to have an inverse, or for something to have an inverse under a certain operation, it must go to the identity. That's what the inverse does. It gives you the identity. When you divide a number by itself, you get the identity for division. So what do you multiply a number by to get the identity for multiplication?
What? 1 over x.
Correct. And of course, the same thing applies at 0. Because 1 over 0 is not a number. Here's a nice one now. Subtraction. What's the inverse for x under subtraction? Remember, x is a real number.
Have to be the same thing as addition, negative x. Oh,
It's x.
Correct.
Achoo. Oh my God. Yes,
Subtract the
correct.
number from itself, you get it back. Right, so now we're understanding. Let's
Yeah.
apply this to matrices. Because this is actually, should have been done in high school, you know. I don't know why we don't learn it until university. As a matter of fact, I didn't learn it at all until I started doing a 4th level math course. Final year math course at UE. I was like, what the hell are you talking about? And I said, oh, we should have known this. But maybe some mistake I just take it off. I don't know what happened.
They actually do it in Cape Mod, sir.
There you go. I'm supposed to do it in high school. I didn't learn
Sir,
it. Mm-hmm.
I learned it. I learned it when I was doing AdMath. AdMath. I learned a CXC still now, but my teacher did bad like you still, but that's I'm learning still. I never get a chance to the Cape.
Oh, okay, Raquel, I understand. I think at the school when I was doing it, the teacher didn't finish the syllabus, so I missed a lot of stuff. I'm hoping that's what happened. I don't know, because a decent teacher. All right, so matrices now. Every matrix has the same inverse type of thing. Of course, for I did give you some notes for the addition and subtraction already. And as I told, what's your name? I think it was Sarah. A female was saying that there's no division for matrices, which is correct. But for multiplication, not all matrices have a multiplicative inverse. And that is a certain matrix. Let's say we're talking about matrix A. The inverse of A would be a certain matrix B, which when you multiply A by B, it's the same as multiplying B by A, and it gives what you call the identity. Now, the identity matrix I mentioned before is a matrix, an n by n matrix, n by n scalar matrix, beg your pardon, where the scalar is 1. And just to make sure everybody understands what this is, I'm just give you a diagram for it here. So I is an n by n scalar matrix. And the scalar is 1. So in, yeah. So it's n by n. I'll try to make it as big as possible. We're going to have 1, 0, 0, right down to the nth 0, 0, 1, 0, right down to 0 again, 0, 0, 1, 0, 0, 0. Across to 1. Right. So there are n rows and n columns. So as you can see, the main diagonal is going to have just 1s, and everybody else is going to be 0. So it's upper and lower triangular, meaning 0s everywhere except the diagonal. And then on the main diagonal are 1s. That's what identity matrix looks like. And the B right here, for the inverse of A, I think you all know this already. How to write inverse. A inverse, or inverse of A. Inverse of A is symbolized by A to the negative 1. Now, not every matrix has an inverse, meaning when you multiply it by the inverse, you get the identity. Not all matrices have it. The ones that have it are called non-invertible, beg your pardon, are called invertible or non-singular.
Wait, so when you said not all matrices that when multiplied by a to the negative 1 power gives you the identity?
Well, what I said initially was not initially. What I'm saying is that not all matrices have this A inverse.
Oh, okay.
So not all matrices have an inverse. But the ones that do are referred to as invertible They have an inverse or non-singular. Those two mean the same thing. So if it has an inverse, it's called non-invertible. These and Pete. If it has an inverse, it's called invertible or non-singular. Boy, I always mix up those two. If it does not have an inverse, it's called non-invertible or what?
Singular.
There you go. That means I hit one. No inverse with it. It's singular. So singular, which is the same as non-invertible, means no inverse. All right, so I'm going to come to the point soon where I tell you how to know if it doesn't have an inverse. Not for today. Today, just give you the definitions and get rid of all of them. I think that covers all those. Wonderful. Praise the Lord. Now, I'm going to show you the hardest way you can possibly use to find the inverse. And then we can stop here for today. So, suppose I give you A, which is normal 2 by 2, because this is even harder when it's a 3 by 3. And the A was 1, 2, 3, 4. And I say, find A inverse. So this is what mathematicians used to do way back when, before they figure out the rules they can use. You say, all right,
Sir,
remember what's first?
So the screen, you're going down too far. You can't. Where you're writing, I can't see what you're writing.
Really? Try scroll down, man. You should be able to.
Stuck. But all right, me watch your recording. Go on, me I listen.
Oh, hold on, try something. I think there's a way, because my algebra class have this problem sometimes. Let me see how this works now. If I do this.
There should be scroll bars at the sides of the screen.
And then do this.
That's how I've been moving them.
Ah, who is that? I never hear that voice before.
Dominic measures,
It's the same thing with me, Dominic. I can scroll it myself at the cursor at the bottom right of the screen.
I'm good to go now. Good to go.
You should be able to see it now, though, because I'll just refresh and come back. Aniva, you seeing it now? Everything good for you too?
Yes, sir, and I can move it now. Thank you.
Yeah, okay, good. You're welcome.
Yes, sir.
All right. So watch this now. We're going to show you the old time method. So to find A inverse, we know that when you multiply it, you're supposed to get identity. Since a 2 by 2, 1, 0, 0, 1. That means that there was some matrix 1, 2, 3, 4. Can use ABCX or ABCD. That should give us the 1, 0, 0, 1. So we end up with a linear system of equations. We know that 1 times A plus 2 times C. Why did I write 1A? A plus 2C must be equal to 1. B plus 2D must be equal to 0. 3A plus 4C must be equal to 1. No, sir, 0. And 3B plus 4D must be equal to 1. All right, so we have 4 equations. Now, I'm sorry I wrote it like this. Matter of fact, let's use some common sense and move this thing around. I don't know why I put them in this order. Put this down here and that one up here. We can combine those. Lovely. So from these two here, we can see that if we multiply the top equation by 3 and subtract it from the one down here, or by 2 and subtract from the one down here, we get a nice result. But you know, me stay ready. I'm going to use negative 3. So negative 3 times that will give us negative 3A minus 6C. I should have labeled them so you know what I'm doing. So this is A and this is B. Or not a space, you know. So I did negative 3A. So You at school, Akin?
No, sir. Sir, you can hear me?
Yeah.
Oh, no, sir.
I'm here. I'm pretty sure I'm hearing Dr. Simpson's voice in the background now. Or who is there with him? Or near him?
I'm muted, sir. Sorry.
No, it's not you. It's not you. If it's not you at school, then it's not you.
Okay. Oh no, some other people at all.
Okay. Oh. No, it's not bothering me. No, I just thought it was him. So, all right. So this multiplies by this one up here by -3, which gave us -3a, -6c, -3 over here. Add them up to the one above it. These cancel. Add this up, you get -2c, and 0 plus -3 is -3. So we have c is -2 into -3, which is 3/2. Over here, before I finish the a, can do the same thing. If I call this c and d, what we can do now? It's the same -3, sure. Right? Invent the wheel. Reinvent the wheel. That would be -3b minus 6d equals 0. Add those up, we're getting -2d is equal to 1. D is equal to -½ So what is A? Okay, working by myself. -2.
No. We say ask what is A.
All right, find B.
Find B. All right, so B, I go B. 2, -1. Hold on. B plus 2 times D, 2 times -½ is 2 times -2 halves. 1. B equal 2
Just give you a
times.
hint. Remember, you have to carry it over.
Oh, maybe carry it over. -1.
Yeah, that's test what about.
1.
Right.
Oh.
So B equal 1. Thank you. So therefore,
bring it all.
So A inverse is, just put the values in there now. So remember, A inverse would be this thing right here. So we have A to be -2, B to be 1, and so forth and so forth. So A, -2, B, 1, C, where is C? 3/2, and B is -1/2.
This is the old way of finding it, sir?
Eh.
This is what they had to do? And I let them teach you as he said.
You think that bad? So was that 4x4? Take long, man.
Oh my God.
But we have learned many shortcuts now. I think about 6 different ways you can solve it now. We have Kramer's rule. Anyway, I'll show them to you as we go through the course, because that's the next topic we're going to look at next class. How to solve these linear equations using them things here. So it's a while ago we had to use linear equations to solve the inverse. We're going to use the reverse now, using inverse to solve linear equations. 3x3, 4x4, 5x5. And you're going to see that they're much quicker than what I've been showing you so far in the first week of the course. All right, we have 2 minutes left and stop right here. Before I leave though, let me remind you, your assignment will be posted tonight or sometime this evening, and it's due by Sunday. Please ensure that your work is done on, it is sent to me in PDF form, one PDF file. Just put them together in one PDF file, not the back of them. If you don't want me to grade it and send it back to you, you can do it in Microsoft Word or just in pictures. I'll grade it, but you're not getting the result. You're not getting the marked paper. Just what mistakes you make. I prefer to have a PDF file. It shouldn't take you long. It takes less than a minute to convert it. So in other words, try to get the work done on time so you can send it in on time, so I can mark it on time and get it back to you on time for your test, which will be on time as well. Any questions before we leave?
Everything good, sir.
All right. Does anyone here know, what's your name? Jody Walker? Nobody? Okay, all right.
No,
I want to make sure she's all right.
No, but I know it's weird talking, but I don't know her like that.
Oh, okay. I knew she had to go to the doctor for something else. Want to make sure she's all right. All right, well, so be it. Maybe she can contact me somehow. All right, people. So see you again on Tuesday. Well, some of you on Monday. Have a wonderful time with your assignment and other things. See you then.
All right, sir.
Sir, have a good
Bye, sir.